Hello everyone, this is Monomatics and we are here with the 8th chapter of Pure Mathematics 1, which is going to be differentiation. So you're gonna learn a few more things about differentiation in this session compared to IGCSE differentiation. And the basics are the same, but you're just gonna use the differentiation in more aspects as for the equation of a straight line. So the questions that you will have in the past papers that we solve together are gonna be the combined questions of differentiation, integration, which is the next chapter, and also the equation of a straight line. So let us get started. Differentiation. The gradient of a function at any given point is worked out using the first derivative of that function. Okay, what does that mean? Okay, guys, let me just find an empty page. Okay, this one's good. So let's say that I have my axis, coordinate axis. This is x, and this one is going to be y. All right, and let me just have a quadratic. The equation of it doesn't really matter. I'm just going to, oh my god. Okay, this one's good. So y equal to f of x. Okay, so y is equal to f of x. And therefore, guys, the curve, the function, because it is a quadratic, okay, doesn't have a constant gradient. You see, the gradient of the function is different at this point. It is different at this point here. It is different at this point and also different at this point. At any given point, the gradient of the function differs and it is not really constant, okay, like a straight line. For a straight line, the gradient is constant, but for curves and for functions of quadratics and above, the gradient is not really the same, okay? So what can we do to find the gradient? Well, you cannot find the gradient for the curve, okay? But you can find the gradient of a curve at a given point. How? By drawing a tangent to that curve, okay? So let's just say that I want the gradient of the curve at this point, okay? So if I want to find the gradient of this point, let's say point P, then I should draw a tangent to the graph at point P, which is going to be something like this, okay? A tangent is a line that touches the graph only at one point, all right? And that one point for this tangent is P, okay? And then this tangent is a straight line, right? Straight line. And you can find the gradient of it. And the gradient of the tangent will be the gradient of the curve at point P, okay? So this is what the first derivative does, okay? When you say f of x equal to y, okay, the coordinates of P are going to be x and f of x, right? The tangent to P will have the gradient equal to f dash x, all right? Or f prime x, which is the first derivative of x, with the value of x being substituted inside the equation, all right? So we just get into more depth through this one in more practice, but this is the thing that you need to know for differentiation, for getting the concept. And they're not going to ask you about this specifically, okay? So you see, I just wrote the differentiations in symbols so you can get them more more easily. So d over dx of f of x will be f dash x, d over dx of f dash x will be f double dash x, which is going to be the second derivative. So the derivative of the first derivative is going to be the second derivative, all right? D over dx of y is going to be dy over dx, d over dx of dy over dx is going to be d squared y over dx squared. And f double dash x and d squared y over dx squared are the same thing. They are both second derivatives. And dy over dx and f dash x are both the same thing again. They are the first derivative. So this is the general form of your differentiation, guys, okay? If you have f of x equal to ax to the power of n, then f dash x will be equal to a times n times x to the power of n minus 1. So you get the original power, you bring it here to the coefficient of x to that power, and then you subtract 1 from this power, okay? The thing that happens right here, and this will be your answer. So, wait, what did I do? Okay, so differentiating from the first principles. So, you should know this one, and this is just telling the derivative, writing the derivative, doing the differentiation from the concept. All right. So it is f dash x equal to limit of f of x plus h minus f of x over h as h tends to 0. So how are we going to do this? I prepared, well, not really prepared, I got this from the book, example 3. And this is proof from first principles that the derivative of x cubed is 3x squared. So I'm just going to write down the formula again. F dash x is going to be limit h tends to 0 f of x plus h minus f of x over h, right? So I'm just going to replace limit h tends to 0 f of x plus h. Okay, what is going to be f of x plus h? Is going to be x plus h to the power of 3, right? Minus f of x, which is going to be x cubed over h. So I'm just going to expand this one. It is, okay, let me just do it here. X plus h squared times x plus h, which is going to be x squared plus 2xh plus h squared times x plus h, which is again going to be x cubed plus hx squared plus 2x squared h plus 2xh squared plus xh squared plus h cubed. So by simplifying, this is going to be x cubed hx squared plus 3hx squared plus 3x h squared. Why I was gonna say cube, and this is going to be h cube, right? And so the thing that happens right here, I just have this result. Okay, I'm just gonna write it here in the original formula, and the expansion, you're gonna do the expansion. I'm just gonna write limit h to 0. This is going to be x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed over h. So x squared, minus x cubed, okay, minus x cubed and x cubed cancel out. And you'll have limit of h to 0 of 3x squared h plus 3x h squared plus h cubed over h. And you cancel out the h, okay? This is going to be limit of h tends to 0, 3x squared plus 3xh. Okay, why is my pen annoying me again? 3xh plus h squared. Now, as h tends to 0, so you put 0 instead of h. then this will be 3x squared plus 3x times 0 plus 0 squared, which is going to be 3x squared. Therefore, shown. Alright? And this is how you do it with the first principles. And the gradient of the tangent to the curve at point x and y is going to be f dash of x. And the gradient of the normal to the curve at point x and y is going to be minus 1 over f dash x. Okay, so guys, you see, we are using the properties of straight lines here. Okay, we talked about tangent and we said that if the point P has x coordinate x, then its gradient, the gradient of the tangent to P, is going to be m, which is going to be equal to f dash of x. Alright? However, we're going to talk about normal too. What is normal? Guys, normal at point P is going to be this straight line which is perpendicular to the tangent at that point. So if this is my tangent, then this line is going to be my normal. Let me just do it with another color. Okay, gold is good. So this is going to be, no, why did it select this one? This is going to be this. Right. So you see, here it is 90 degrees. So if this is n, the normal line to point P, okay, is going to be what? Perpendicular to the tangent at point P. All right. So since, okay, if we are saying that, let's say that this one has gradient m, okay, gradient m, and this one has gradient m prime, then I know that m times m prime is going to be minus 1. So m prime is going to be minus 1 over m. And since I know that m is equal to f dash of x, so m prime is going to be what? Minus 1 over f dash of x, as I had here, right? Let me just go back to the content right here. See? So this is simply the properties of straight lines, and this is nothing really that big of a deal, okay? And you know all about these ones. And question 14, a 10 marker. Okay, this is from chapter review, and I took it from the book. We're gonna solve it together. So let me use purple. The normals to the curve 2y equal to 3x cubed minus 7x squared plus 4x at points origin and A meet at the point N. Okay, find the coordinates of N. Okay, so I have two straight lines, right? So I have two normals, right? Let's say normal to O be L1, and normal, I'm not gonna write it again, to A is going to be L2. Okay, so I have two lines, L1 and L2. I'm just going to rewrite this one, so the y is going to be the subject. Okay, so 2y equal to 3x cubed minus 7x squared plus 4x is going to be y equal to 3 over 2 x cubed minus 7x squared, no, I'm sorry, 7 over 2x squared plus 2x, right? And then I'm going to find f dash x. We don't have f of x here, so it's going to be dy over dx. dy over dx is going to be 9 over 2x squared. Okay, I multiplied this one by 3 and wrote 3 minus 1 here, right, which is 2. Then minus 7x. Okay, I multiplied the 2, and then what happened? 2 and 2 cancelled out, and 2 minus 1 is going to be simply 1, which I don't write. Plus 2. Here it is 1, multiplies, and x 1 minus 1, which is 0, which is 1. So I don't write it. And now, for L1, let me just drag this page, okay, to another page. Okay, right, so we have more space here. Now, I'm using dy over dx, okay, with x being equal to 0. This is going to be 9 over 2, 0 squared minus 7 times 0 plus 2, which is going to be 2, right? Guys, this is the gradient of tangent to the origin, okay, for the curve. But I want the gradient of the normal, not the tangent. So I'm just gonna write minus 1 over f dash x, which is going to be minus 1 over 2. This is the gradient of normal to O. So I'm just gonna write L1 and y equal to minus 1 over 2x plus c, which passes through 0 and 0. So it is going to simply be y equal to minus 1 over 2x. This is the equation of L1. And I'm just going to put it aside. And I am going to have dy over dx, okay, with x being equal to what this time? With x being equal to 1 and 0, which is going to be 1. Okay, I want the x coordinates. So it's going to be 9 over 2 x squared, which is going to be 1 squared. And I forgot the equation. Okay, minus 7 times 1 plus 2, which is going to be 9 over 2 minus 7, 9 divided by 2 minus 7 plus 2, which is going to be minus 1 over 2. And now, this is the gradient of the tangent to point A, okay? But I want the gradient of the normal. So I'm just gonna write minus 1 over f dash x, which is going to be minus 1 over minus 1 over 2, which is going to be 2. All right? So line L2 is going to be y equal to 2x plus c. That passes through points 1 and 0. So if I put 0 equal to 2 times 1 plus c, then c is going to be equal to minus 2. And so the equation of my L2 is going to be y equal to 2x minus 2. And I have this one as well. Now, I want the intersection points, right? But before that, guys, I'm just going to tell you about something. You see, you can use your calculator to ensure that you got the answer right, okay? Using this button, okay? Shift and this button. You see, I can write my formula here. 3 over 2 x cubed, 3 over 2 x cubed, yes, minus 7 over 2x squared, minus 7 over 2 x squared, okay, plus 2x, right? Plus 2x, okay. And I want the x to be 0, okay, for the gradient of the tangent to O, to origin. So this is going to be 2, right? Which I figured out here. So my answer is right. And I'm just gonna do 1 as well. This should be minus 1 over 2, right? And yes, this is minus 1 over 2. And that's how you check your answer, okay? Using your calculator. And then, okay, I was gonna find the coordinates of intersection point N. So 2x minus 2 and minus 1 over 2x. We know that we are going to equate the two equations, right? I'm just going to write 2x minus 2 equal to minus 1 over 2x. So I'll have 5 over 2x equal to 2. So x is going to be equal to 4 over 5, right? And so I just put this 4 over 5 in one of the equations. I want to put it in y is equal to minus 1 over 2x, which is easier to deal with. Okay, and this is going to be minus 2 over 5. And therefore, the coordinates of point N are going to be 4 over 5 and minus 2 over 5. Just to check my answer, I'm just going to put 4 over 5 in this equation as well. So 4 over 5 times 2 is going to be 8 over 5, 8 over 5. Minus 2 is going to be minus 2 over 5, which I figured out here. So my answers are correct. And this was 7 marks. And B, calculate the area of the triangle OAN. Okay, let me just have a quick sketch. Part B. So I have, your sketch doesn't really need to be that big, okay? We just want to know how to find out the base, the height, because you're not gonna have those complicated questions of non-regular triangles, non-isosceles, right-angled in your exam. So n was 4.4 over 5 and minus 2 over 5. So it's going to be here 4 over 5 minus 2 over 5 minus 2 over 5. And I have my origin and a, which was 1 and 0, okay? 1 and 0. So this is going to be my triangle, okay? And I want to find the area of this one. So what is the height of it? The height of it is going to be 0 minus 2 over 5, right? Times base. What is the base? The base is this whole line, okay? Which is going to be 1 divided by 2, right? So area of the triangle or area of, it was N, it was O, this was A, O, N triangle is going to be 2 over 5 times 1 divided by 2, which is going to be 1 over 5. And that's whatever that you needed to know for differentiation. And as for the next session, we're going to cover integration, and then we'll finish the whole pure mathematics one and go through the past papers. Till the next session, guys, see you and take care.